Last time, indeed last year, we were looking at using the new TimeProvider class that came in with .NET 8 that allows us to mock time for when we're doing unit tests. And I did that by using the N-substitute mocking framework on the TimeProvider to do that mock. But what's also provided by Microsoft is actually their own implementation of a mock version of this TimeProvider, which you can use, but actually it has a few drawbacks, you might even call them bugs, and so I thought in this video we'd take a look at that fake TimeProvider that they provide and show what the problems are. So let's just have a quick recap of what we had. Do have a look at that previous video if you want the detail, but basically we had this application, and if we run it up, we had this Blazor application, and what I put in was this ability to cheat it. So if I check that box, we go to 5 seconds before the hour, and then when we hit the hour, we can see that it's chiming as an animation. So that's what we've got there. But more importantly, for what we were looking at in terms of unit testing, was we had various unit tests that we've got in there. So a number of them using XUnit and also using N-substitute, and those are all working. You can see here, we've got the idea that we had our substitute for the TimeProvider, and then we had to set up various calls like the get UTC now, and that was returning a particular time that we wanted. So what we're going to do is, instead of using N-substitute, use this predefined mock. And so to get hold of that, we need to go to NuGet. So if we just go to Manage NuGet Packages, and then we'll search for TimeProvider, and then testing is what we want there. So there's the package we want. Let's install that. And then go back to our clock tests, and let's go to that creation test to start with. So the very simple one, and just to verify what's happening, rather than having that substitute, we're going to say new, and then fake TimeProvider. That's what we just got from the package we added. So it's popped in the using statement there. And just to verify that works, let's just run those tests. And it's not doing very much, but it's showing that that fake TimeProvider is derived from the actual TimeProvider in just the same way that the mock we had with N-substitute was. Now let's start making that do some more interesting things. So let's go into this next one. So here we got the test for displays the correct time. So there we've got the hours, minutes and seconds and what the display should be. And again, this is where we're having to do that mocking. So what we're going to do instead is just say provider equals new fake TimeProvider, and then that actually can take as a parameter to its constructor the time that we want it to be at. So if we just take that date time offset that we were using previously and pop that in there, and so now we don't need to specify what it's returning, we've just set it to that value, and so that should be a slightly neater way, not a huge improvement, but if we run that, that should be working fine. So nice thing we can do, we can just have this fake TimeProvider, set it to whatever date time we like, and it will return that when it's being looked at. So that displayed time, remember, is just using the TimeProvider that we've injected, getting the UTC now and doing some formatting on it, but the UTC now it gets there will be the one that we passed in there with the fake TimeProvider. So for a simple case like that, it's working. Let's have a look at the next thing that we wanted to do. And in the next test, we wanted to make sure that the tick event is being fired. So what we've got on the clock is this time changed, which should be firing once every second. And that once every second is done by having a create timer again on the TimeProvider. And that was quite tricky to do our own mocking from, because we've got to actually have this mock call to create timer, and then we've got to call that tick callback for ourselves to make it work. So can we do that using the fake TimeProvider? Well, let's go through the process of that. So again, let's have a new fake TimeProvider, and let's set it up with a particular time. So we can just copy what we had up there, except this time we don't have the variables for hours, minutes and seconds, but it doesn't matter really what they are in this case. So we'll just pop those in as any old values. And then life becomes much simpler with this. We don't need to actually get hold of that tick callback or anything like that. All we need to do is, once we've passed the provider into the clock, then we can see what we're doing. We've got this fire count. We're going to count the number of times that the event's called. And to make it be called, all we have to do is advance this fake TimeProvider. So it's got a method on it called advance, and that can move time forward by a time span. So if we move it forward by 1 second, then because this time changed event is supposed to fire every second, then that should fire once. So I'll say new time span, and then give it 0 hours, 0 minutes and 1 second, and then that should cause the event to fire just once. So if we run the tests again there, then we can see that's all still working fine. So again, rather simpler and working okay. And if we just show how this works, if I, for example, were to change that to 10, so we're advancing 10 seconds, then it will actually fire the event 10 times, which obviously means the test will fail because it's only looking for it firing once. So we can see there we've got that failed, and if we look at the detail of it, you can see that it's actually fired 10 times. So by advancing it 10 seconds, then it's just caused that to happen 10 times. So that's quite neat. Obviously we don't want that, we just want the 1 second in there to have that working. So that's all working pretty well, but now let's look at probably the most complicated test. This was making sure that the ring count was correct. So the idea of this was that if it's 5 o'clock, then it should chime 5 times. If it's midnight, so 0 hours, then it should chime 12 times, and that sort of thing. And that was a little bit complicated because what we have to do with that, if we just look in the clock itself, then we can see here that we had to have the test when it's doing the ticking to make sure that it's on the hour, so minute is 0 and the second is 0. Then it does this fire ringing for the hour that we're on, and then it had to set up another timer which would then be called 12 times or whatever it's going to be depending on the hour, and that's where we invoke that ring changed event with either the on or the off, because as we saw from the animation, it goes on and off alternately. So that's what we had to do, and that was quite tricky because we had to, as well as mocking the time to be exactly on the hour, we also had to be mocking the create timer both for the general ticking once a second and for the half a second that it was doing on the ringing. So that's what we've got there. So let's see if we can simplify that with the fake time provider. So once again, let's turn that into a new fake time provider. And what I'm going to do with this is not actually set it bang on the hour, but set it to just 1 second before the hour so that we get the idea of going through the hour, which is what we want. So there it is on the hour coming in as a parameter of the test, but then I'm going to subtract from that 1 second, so we'll have a new time span, and again we'll put in 0,0,1 on there, and that should set us up to just 1 second before the hour, so we can then go through it. Then we can do a lot of simplification because we don't really need any of this now. So we can go straight through to the clock, passing in the provider, and then we're there counting the number of ring-ons and ring-offs for this state that toggles alternately between them and checking they are the right amount. We don't need to have any of this. All we should need to do is advance that provider by a certain amount of time. So remember here, we advanced it by just 1 second. Well, here what we need to do is advance it by more than the maximum number of chimes we're going to have. So we've got a maximum of 12 chimes. So if we advance it by a time span of, let's say, 13 seconds, then that's more than enough and it should chime the appropriate number of times. And so that should be working nicely. But actually, this is where the problems start to occur. So if we go to the tests here and run them, then you can see we're getting errors on that one. And if we look at what's happening, we can actually see that in all of these, it's not chiming at all. So whatever it was we expected, we're getting 0 for the actual number of chimes, which is rather odd because we've already seen that if you advance it by a number of seconds, it should call the timeout multiple times, just like we saw in the previous example. So let's start debugging that and see what's going wrong. And so remember what we saw here, the way that this is meant to work is this tick callback is the one that's called every second, and if that one hits the hour, then it will call the fire ringing, and this one will get called as well. But that one, it seems, isn't getting called because we were getting 0 for that counter chime. So what I'm going to do is put a break in here and see what's happening. So got the break in there. Let's just run one of those tests in debug, and we'll hit that, and we can see it's looking for that time, But if we look at what the time actually is there, which we can see down here in the locals window, so there it's 23:59:59, so 1 second before, like we set it up. So obviously that's not going to hit. Let's go around again. And this time, if you look at the time, it's midnight and 12 seconds. So if we just keep hitting go, it's hitting this callback the multiple times. Should be the 13 times we asked for it. But the problem is, it's not incrementing the current time that we're getting by 1 second on each of those. It's advanced it all the way to 12 seconds past, and then it's calling it multiple times. So what we should be seeing is each time we go round, the clock should be advancing by 1 second until we get to the end of it. But in fact, what's happening is it's advancing all the way by 12 steps, and then we're not getting any more. So that's not really what we wanted it to do. And that is the first bug that we can see in this fake time provider. And the way to get around it, as far as I can see, is we have to do this. We can't just advance it there by that 13 that we've done. What we've got to do is have a loop. So we're going to say for, and then int I equals 0, I is less than, and again we'll put the 13 in there, and then advance it by just 1 second on each one of those. So it'll still go forward the same amount, but it will go forward in steps of 1 second. So let's run that one. And it's still getting errors, but you'll notice it is getting a slightly different error. Previously, the actual was 0 on all of these, but now you can see that the actual is 1 more than it should be. So when it's supposed to be chiming 5 times, it's chiming 6 times. When it's supposed to be chiming 12 times, it's chiming 13 times. So we've solved one problem, but we've hit another one. And again, if we look at what's happening here, so let's go to the clock and go into this ring callback, because this is the thing that apparently is being called too frequently. So let's just put a break in there. And also we can see that the way that stops is it's terminated by when this countdown hits 0, then we change that time and have this infinite time span, if you remember when we did this in the previous video. And the infinite time span basically means turn off that, and so it'll stop working. So let's also put a break in there as well. And let's go for one of the shorter ones. So there we've got the one that should be called 3 times, but it's going 4 times. So let's debug that one. And so we're hitting the ring change, that's fine. So that's once. Remember, we go through this 3 times for on and 3 times for off, so it should be 6 overall. So if we just keep going through, that should be 4, 5, 6. And then on that one, the countdown has gone to 0, so that's all working fine. And then we effectively turn off the timer. But then the problem is, we come back in a couple more times, and then finally we get the error because we've now counted too many. So for some reason, the way that this fake time provider terminates is slightly different from the way the real one did, in that even though we've changed that to infinite, it's obviously got some of the callbacks queued up already or something like that, and we're getting too many of them. And the only way I can see to fix that one is quite nasty. At least the previous problem, we only had to fiddle around a little bit in the test code. But to make this one work, what I think we're going to have to do is, in here, put an extra check and say if countdown, and then make that is greater than 0, so that even though countdown hitting 0 should have turned it off, when we come back in, we can at least check again, and so that should leave things working. And so if we do that and run the tests, then we can finally see it's working okay. But we had to alter the code to solve a bug in our tests. That bit of code, that if statement, was not necessary for the actual functionality. It doesn't hurt the actual functionality, but it kind of goes against the ideas of testing. And so, although the code here is simpler than the code we had before, this fake time provider, because it's got those 2 bugs at least, those are the only ones I've found, I'd probably not use it. I'd stick with what we did in the previous video of using end substitute. So that was just it, just something that I thought would be worth looking at because it's slightly different from the way I did it, but explains why I did it the way I did it. Next time we're going to be looking at some more new .NET 8 features, but if you enjoyed that one, do subscribe, do click like, and I'll see you next time.